Hello everyone, thank you for making the time to join me today. My name is Vicky Giavelli and I am the Director of the Performance Engineering and Virtualization Product Management team. It is a pleasure to connect with you on this session where I will talk about performance, the journey from performance testing towards performance engineering, and how the micro-focused performance engineering and virtualization solutions can help you to overcome digital challenges and deliver high-performing applications that exceed customer expectations with a superior user experience. With that being said, I hope you have your coffee and headset ready. Let's go ahead and get started. Great performance is the foundation of success. Successful organizations accelerate their digital transformation by putting the customer experience first. And why? Because there is a direct correlation between increased customer satisfaction and increased business results. Customers, especially digital natives, are impatient and unpredictable. Their loyalty will likely shift to the brand that meets their needs in the now. The challenge is that software and applications are becoming more complex, making it more critical than ever to quickly deliver great performing applications that are not only resilient but also satisfy user expectations. Here on the screen you can see some numbers from the World Quality Report that illustrates the relationship between performance engineering, the user experience, and the role they play for success. As we discussed earlier, there is a direct correlation between increased customer satisfaction and increased business results. It is pretty clear that improved customer experience drives differentiation and revenue growth. The quality of interaction between customers and your applications, whether it's through web, mobile, or any other channels, influences their choice, their loyalty, and their continued engagement. But all too often, performance testing is viewed as a last-mile effort. Regrettably, saving performance testing to the end results in poor application design, higher cost of change, release delays, production issues, and not so great user experience. Here are some additional cost figures, but what I found interesting on this page are the statistics when it comes to user behavior. 57% won't recommend a business if the mobile app access is poor. 85% expect better performance from the mobile app than from the desktop version. And customers are quick to abandon websites. That was a 4-second wait you just experienced. And that's how long 61% of customers will wait for an application to start before they will abandon it. 57% will abandon a site if it doesn't load in just 3 seconds. Applications reviews and social media buzz are what companies are having to pay attention to these days, and the faster they can answer bad reviews, the better off they are. So we see how important the user experience is. Clearly, one of the most important things at stake for a company is revenue loss. Online purchasing continues to grow. In 2020, 5% of the total online revenue was spent on Black Friday, just Black Friday alone. That's about 10 million per minute. Black Friday and similar events occur for an unlimited time. However, we also need to make sure that the customers are always receiving the best user experience, because we already know what will happen if they don't have the best user experience. Let's explore what are some of the challenges the performance teams are experiencing these days. When we talk about continuous testing, agile and Devops methodologies, we can highlight many different benefits that they bring. But these trends also introduce new challenges that puts pressures on performance teams. For example, little alignment. There are wider gaps between development and test efforts, and that leaves all the burden to the performance teams. Will also increase the likelihood of developing poor design applications today and creating future technical debt. There are a lot of things going on. There are more technologies and services to test, and that leads to making choices on what and where to test. This creates another gap in coverage that could be tragic later on. The application complexity also means that the root cause analysis becomes more complex. It is getting harder and harder to quickly pinpoint where the issues exist and can create unexpected delays while we are trying to figure it out where or what is the problem. And lastly, with more to test and increasing loads, the overall maintenance of test assets and infrastructure cost will increase as well, adding pressure on human resources and tooling budgets. The expected conclusion here is that the cost of poor application performance is expensive, it has a direct effect with the user experience, and cannot fall on quality assurance alone. Performance must become everyone's responsibility, from the designer, the coder, the developer, the QA tester, to the performance engineer. So the teams design better performance software from the start as they quickly root out issues before production. With the right performance engineering solution as the load runner family, you should be able to leverage your current environment and infrastructure and making all the necessary pieces available to all the people in teams who are now part of the performance process. According to Forrester, any agile development process needs to build in quality from the beginning. This means that performance needs to be on the developers' and tester minds from the start. Other forms of testing have already shifted. 81% of companies practicing agile perform unit tests on their code, and 53% automate functional testings in their sprint. But only 26% execute load and performance tests in their sprints. Agile adopters have always required to put more testing into the hands of developers. Yet Forrester Analytics data shows that 52% of global developers still spend less than an hour per day on non-functional testing. And of course, it can be worse. They will not spend time at all. In order to adopt these methodologies and leverage all the benefits, we must adopt a performance engineering approach. So let's talk about the need to shift from traditional performance testing to performance engineering. To deliver at the speed the business requires, organizations need to evolve from a siloed late-stage performance testing model to one that builds quality metrics into the release requirements before development begins. To meet the demands of rapid application delivery, modern software teams need an evolved approach, one that goes beyond traditional performance testing and extends all the way into the end user experience. This path to performance engineering is definitely a journey. It will take time to adjust people and procedures, break down walls of siloed teams, and shift the prevailing paradigm in order to change processes and behaviors, but there are so many benefits when it comes to performance engineering that we will discuss in the next slides. To some people, performance testing is sequential. It's done at the end of the development cycle and owned exclusively by the QA team. The process happens only once the application is pretty much ready to be deployed in production, leaving no room for suggestions or improvement from QA to development or any other stakeholder that is involved. This, unfortunately, has an effect on the end user experience. Sticking with the notion of performance testing as a late-stage risk assessment, when we are just basically doing manual tests, it will cover a very narrow scope. Does it work? Yes or no. Can it handle load? Maybe, but we don't know anything else beyond that. So there is no room to share feedback, suggestions, improvements, and there is no collaboration. When it comes to performance engineering, it's a continuous process. On Agile and Devops teams, development and testing happen simultaneously, requiring test creation and execution earlier in the life cycle, even before coding begins. Since there is always more to test than time to do so, performance teams need to leverage information about what matters most to their application users and what real-world production behavior is. This requires them to fully engage in the DevOps processes and gain access to and also to leverage production analytics to focus their testing efforts. Continuous feedback loops are essential here. Also, they need to ensure performance is not seen as the bottleneck, but as a trusted partner, and the performance products needs to execute and provide superior performance testing while making the cycles shorter and efficient. One of the main goals and ultimate results of performance engineering is around the optimization of the user experience. But like I said, there are many other benefits. For example, improved time to market. Developer efficiency is key to rapid delivery. Therefore, it is very important to allow developers to focus on dev tasks while at the same time they are embracing and participating on the performance efforts. The competitive advantage. In the digital era, it's extremely important to deliver and maintain high-performing applications that will exceed the customer expectations. A good performing application translates in happy and loyal customers. And control application cost. As important is the user experience and the direct effect on the competitive position, is also the ability to keep cost when it comes to infrastructure, for example, in line. I think we have all seen this graph showing that the later in the development cycle a performance bug is caught, the more expensive it will be to fix it. Adopting performance engineering and introducing performance testing during the actual development, where developers both manually and automatically trigger tests during build cycles, will solve a lot of the issues in the long run. It forces testing to occur earlier and more often. Let's talk briefly and walk through the modern software development lifecycle and the role of performance engineering and their benefits when it comes to a sprint. This is going to be the example. Here it goes. During design, application features are designed from customer feedback or responding to a market trend, closing application gaps between competitors, for example, or fixing a security vulnerability. During the development phase, the developer will check in changes for a nightly build. During the testing phase, several types of testing are happening. The performance engineer runs baseline tests to validate performance. The security tester runs penetration and compliance tests, and the QA and dev tester runs functional and automation tests. During deployment, the operation teams and the DevOps will deploy changes to production. The next phase is monitoring, where the monitoring team captures and reports on synthetic and real user monitors. Now, staying with this modern software development lifecycle, we can see how performance engineering enables DevOps. During development, we can leverage service virtualization in order to improve developer efficiency by allowing them to continue and move forward with the development, even when some services or components might not be 100% ready or finalizing. We can virtualize those, and we are eliminating dependency. This is a key enabler for shift-left performance testing. In the context of testing, there are many use cases. For example, testing is something that needs to be addressed to the entire software development lifecycle. You plan tests in advance, you write tests for automation, for example, and then you submit your code and tests all together to forever live in the CI pipeline. So in this case, anything breaks, you get to know it as soon as possible with the opportunity to fix it. Performance engineering enabled through the entire DevOps pipeline. The ability to reuse assets, not only functional scripts in the context of performance, but also for monitoring purposes. This is a great benefit since it reduces the overall scripting time, but also the maintenance associated with the assets. And again, a great example of collaboration, shifting to the left and to the right. The integrations with APM tools during test execution will provide insights around the real user experience for enhanced user engagement and insights. Seamless integrations with virtualization solutions like SV and network virtualization will also help us to increase the overall user experience. Multiple integrations with CI/CD tools will give great flexibility and allows your agile testing and development teams to run performance tests as part of their builds in an easy and automated manner. With a performance engineering approach, you can leverage data coming from production in order to build more realistic tests and reduce risk and assumptions. All data from test, monitoring, and production can be correlated to establish trends and patterns and predict application behavior. Let's explore more benefits of performance engineering. Performance engineering accelerates development. How? Simulating and virtualizing services, APIs, sensors, devices, and even other applications, all in the same testing development environment, eliminating dependencies and quickening development. Providing insights that can identify usage patterns, bottlenecks, defects, and pinpoint at opportunities for optimization. Reuse of developer assets, such as unit tests for early performance insights. Performance engineering enables predictive performance. Very important is the reusage of multiple assets, and to enable shift-left performance testing is the ability to provide the developers with tools that matches their skill set. Here, load runner developer, it's going to be key, but also the ability to reuse, like I said, assets preferred by developers, for example, JMeter, Selenium, Gatling, and more. We can also virtualize application dependencies for improved speed, efficiency, and reduced risk, as we have discussed already with service and network virtualization. We can drive performance testing from continuous integration and get immediate feedback. As soon as something in the CI pipeline is not looking as expected, we have the opportunity to fix it. And predictive performance analytics. Automated and graphical analysis can significantly help to focus your testing efforts. Ultimately, you want to identify problems faster, and with the load runner family, you can use predictive analytics to help you understand anomalies and problems in real time. Performance engineering enables intelligent monitoring. Performance script can be leveraged in the context of monitoring, facilitating teamwork and collaboration while sharing assets. Diagnostics and monitoring data from testing can also be reused in order to define thresholds in production. And you can capture real user behavior from web and mobile users to understand usage, demographics, and generate test scripts automatically, so you can get a better sense of how and what your users are doing in production. How load runner solutions can deliver a superior user experience. As we have discussed today, the user experience plays one of the most significant roles during short development lifecycle, frequent releases, as well as changing market needs. In response to this particular trend around the user experience, we need to reconsider the priorities in favor of a consume-focused approach for quality standards on every single phase of the software development lifecycle. When done right, performance engineering enables QA engineers, testers, and developers to build all the necessary performance metrics from the initial design. Load runner can help to deliver the best user experience, not only providing a performance engineering approach, but also with the most accurate emulation using a combination of these capabilities. For example, through client for scripting and the ability to gather client-side metrics, advanced scheduling and modeling of real-world scenarios, network emulation and service virtualization, and load generation from different geographic locations. When you combine all these capabilities with the ability to start performance earlier in the development cycle and the opportunity to share feedback immediately among all the team members, allows you to ensure high quality and a remarkable user experience. We have talked today about performance engineering and all the benefits. At MacroFocus, we support a proactive, continuous performance engineering discipline that includes 4 key attributes: the expansion of performance testing to new roles, tight integration into the CI/CD process, end-to-end performance monitoring, and continuous improvement that altogether translates in a remarkable user experience. If you want to learn more about the LoadRunner family and how we can help you to deliver an enhanced user experience with the best quality, please visit our website, the online help for all the tech details, or leave me your contact and we can discuss further offline. Thank you very much for your time today. I hope you have enjoyed the session and will continue to participate and to enjoy Micro Focus Universe 2022. Thank you very much again and stay safe.
Get social with us. Twitter, LinkedIn, Get Social, Micro Focus Universe.